Imagine you are working in an e-commerce company and want to build a cutting-edge QA model that will answer the user question based on a product review. In the journal QA model, we pass the context and a query. But in the real world, user will only provide the question. So how will you select the most relevant information from the reviews when the user asks? Also, the model's input are of the fixed length and the review can be of thousands of the characters. Here is where the LangChain comes in play. But if you have seen my previous video, there is a problem in the LangChain that we cannot process the input. Thus, we build the entire pipeline by our own. This is the workflow of our project. We have the review about the product, where the review are stored in a vector store, either in a Pinecone or locally. The multiple vector becomes our knowledge base. When the user query about the product, it first searches in our knowledge base and we get the rank result. The result along with the query are passed to the LLM and we get the final answer. This is what we are going to build together, and so let's get started. So first step is data collection. We'll use subject QA data for the simplicity. The subject QA contains various sections such as books, electronics, grocery, movies, restaurant, and TripAdvisor. The each section are further divided into 10, trace, and dev. Here, we'll use electronics as our data. You can download any section for this project. As we are building our project on top of the files, so we require files for semantic search. And for embedding, we require sentence transformer. You could use Instruct embedding as well, but for simplicity, we'll be using sentence transformer as most of you might know about it. But I will show you how to use Instructor as well. The data contains review, what we are most concerned about, along with the query and the answer. We will use paraphrase MPNet base from sentence base for embedding and encode our review column from our data. This is where we can use instructor embedding instead of sentence base. We will just load the instructor from the Hugging Face and use it instead of sentence base. To create a vector store, we require files. First, we get the shape of our embedding and create a vector store for our embedding. Now, we normalize our embedding and finally add all the embedding to our vector store. This is a place where you can use Pinecone or ChromaDB. I had a plan of doing this using the Pinecone, but free version of the Pinecone is super slow. Now we have created our knowledge base. The model we'll be using for this project is Mini LM from DeepSeek. You can use Google 25 or OpenAI if you like. To load the model, we can import the auto tokenizer and auto model from the transformer and pass our model checkpoint to it. Downloading will be automatically started. We can use a pipeline from the transformer for the inference. That will save us most of the time to tokenize the input. Now it's time for query. If a user asks the question, we will first encode the query through a sentence transformer and normalize the embedding as we have done for the review stored in knowledge base. And then we search the most similar review from our query using semantic search. Here we'll use L2 distance for the search, but you could use question similarity as well. Just change the index flag L2 to index flag IP. This is the reason of doing normalization, as normalized inner product is a cosine similarity. The search returns the distance as we are using the L2 distance for our similarity and ANN as index to the shortest distance vector. We will extract the content from the particular index and pass it to our pipeline module along with a query to get an answer. Now it's time for testing. Suppose user asks the question, is book good for reading? We can get answer to it. The answer seems not perfect, but can be made if we filter out the data according to the category of the question asked and search for the context in that filter data. That way we can get more accurate answer than we get right now. So that I leave to you. That's all for this video. If you like this video, please like, share and subscribe for more. This is the last topic for this series, as concept remains the same for every topic now, even if you use LangChain. We will move to the image generation in our next video. We will explore stable diffusion and projects such as talking face using the audio and modify already present model for our use case. Till then, keep learning and comment if you have any question. I will love to help.